So first, I will introduce myself as one of your speakers. My name is Sarah Grace Mitchell, and I'm a Business Development Manager with CORYS. I have a background as a process engineer working in oil and gas, and I will let my co-host Dave DeGrule introduce himself as well.
Thanks. I'm David DeGrule. I'm the Advanced Application Manager at AXENS North America. I also came from process engineering, but I've been doing simulation development for the past 20 years or so.
Thanks, Dave. So today we are going to start by giving you a brief intro to CORYS and AXENS, as well as our history together. Then we're going to talk about our training model. Then we will cover a refining case study on the use of standard models in the cloud, and we'll talk about cloud architecture. Then AXENS is going to describe troubleshooting. Then we will have a demo of both the Indiss Plus modeling platform as well as AXENS Connect In. And afterwards, we'll have some time to answer your questions. So we'll start with the intro to CORYS and AXENS. So at CORYS, we offer a wide range of solutions based around simulation. Our primary offering is high-fidelity custom models of your facility, which act as a digital twin and can be used for troubleshooting and procedure validation and more. We're DCS independent, and our software is compatible with all major DCS. In addition to custom models, we also provide lower capital cost standard models. Alongside our models, we offer custom training solutions, such as our companion training manual and Train the Trainer services. And we also have a 3D virtual reality training product.
AXENS is a fairly large organization. We deal with process licensing, catalyst and adsorbents development and production, and also furnaces and modular unit production. We are in the, we like to deal with the entire life cycle of the plant, from conception through engineering and construction, and finally through startup and past startup into the training and life cycle management of the plant for improvements and follow-up going decades into the future. CORYS and AXENS have been working together for about 20 years at this point, but in 2019, we decided to formalize that agreement and put together our simulation, their simulation expertise with our knowledge of process to put forward a simulation package to our clients.
As Dave just mentioned, CORYS and AXENS do have a decades-long history of jointly creating high-fidelity simulators. So AXENS is the process licensing expert with startup experience that they contribute. CORYS provides the simulation expertise as well as our proprietary simulation platform, which you'll see a demo of in just a little while, Indiss Plus. And together we provide high-fidelity lifecycle simulators for our customers. If you're not familiar with the concept of a lifecycle simulator, it's the idea that dynamic simulation provides value across the entire range of the life of the plant from feed to operation. Toward the beginning of the process, we can help with process and control studies, as well as testing system configurations and graphics. The most known use of the OTS is to train operators, which can occur before the plant even starts up. And in many cases, it can expedite that startup. It can also validate the new procedures for startup and operation. And then once the plant is operational, dynamic simulation is useful for continued training, debottlenecking, and more, as it allows you to test different plant scenarios without impact to the physical plant. So now we're going to tell you some more about AXENS training model.
So at AXENS, we know that there are several different reasons for training, and the primary reason for training is to improve safety. We want to avoid any possible dangerous situation. We also would like to reduce emissions to zero if at all possible. And that's across the board. Every unit wants to do this. Additionally, we'd like to improve operability. And this means we want to make everything run smoother. And we do this by having operators who know how to respond to different changes in the unit operation and to different requirements from the unit. Generally, we like to recommend every 1.5 to 2 years that the operators and engineers on the unit be retrained. And this can be a shorter refresher training for the purpose of making sure that everybody knows the unusual situations that can occur and how to respond to them. Our model for training is to combine the classroom training with the simulator training, so that any time we have something in the classroom training which can be demonstrated using a simulator, we try to demonstrate that on a simulator so that the knowledge is implanted better in the trainees' minds. But also it allows for breaking up the monotony of a classroom training. Additionally, we like to tailor the courses to problem solving and learning to operate the unit directly. We've seen good results of this over the past 10 years or so. We do have an operation-oriented approach. That means that the entire goal is to provide safe and reliable operation over the course of the life of the unit. And that means that we try to focus on the operation directly. So for troubleshooting, for unusual operations, training to make those work better and have better responses. And we've seen the simulator approach work very well for both pre-startup training and for refresher training. And once the simulator is developed for a unit, it can be applied to repeatedly for that unit. And so refresher trainings can be shorter generally and less expensive, and allow for refreshing the knowledge and for education of new hires and replacement staff. And with the combination of all this features, we've seen that the improvement of on-stream factor can be very high, especially with good maintenance practices.
Many of you are probably familiar with the learning pyramid, which relates different methods of learning to different retention rates by participants. And while these sources vary slightly on the exact percent of retention, they all agree that as you move down the pyramid, retention of material increases, with the lowest retention being traditional lecture style instruction. The three participatory methods, discussion, practice by doing, and teaching others, all have the highest retention rate. So as companies are looking for new and engaging ways to train the next generation of operators and engineers, it's important to center your training program around these methods. Specifically, dynamic simulation falls under the category of practice by doing. And for many of the next generation of operators who are millennials and Gen Zs, it can feel a lot like the video game type of environment that they grew up in and are familiar with. So now we're going to move into our refining client case study. Before we get into that, I want to cover briefly the difference between standard and custom models for everyone. The most important thing to remember is that standard and custom models are both high fidelity, rigorous models based on real world units. Standard models, sometimes called generic, however, are not customized to your unit. So they have some equipment differences and the tags won't match your unit either, as they would in a custom model. Standard models are great for common processes and they're much less expensive than a custom high fidelity model. So this is the case study of one of our refining clients who had minimal experience with simulation-based training, but they knew they needed it as their workforce was aging and they were losing valuable plant experience. They also had to train across multiple different refining sites, which operated independently from one another, and they had a mixture of Delta V and Honeywell DCS across their sites, which mean multiple HMIs for the simulators. They were also under a schedule and budget constraint from their management. So we worked with them in the bidding stage and developed a solution, providing them with standard models covering their most common process units across the sites. And standard models were a good fit for them because their sites had similar but not identical units, and cloud deployment allowed all of their sites to train from anywhere at any time, which has been especially helpful in this time of remote working. The hardware cost to them was minimal. It was just desktop computers. And the models are being provided with both Honeywell and Delta V DCS, which is selectable by the instructor, allowing the trainees to train using the same DCS that they have in their plant. The client purchased a subscription for these models, which is a fraction of the cost of owning custom models, which let them stay within their management approved budget. Because of their limited experience with simulation-based training, our training experts also consulted for them and developed a corporate training program master plan, which structures their new training program to incorporate the simulators. Included in that was the development of companion training manuals, which we co-developed with their SMEs to provide a complete classroom curriculum and training scenarios for each site. So these are some of these standard refinery models that we can provide. We provide both component or small system models, as well as models of entire refinery units. These models are available in the cloud on a subscription basis with no software license fees. And we can also provide standard models for ethylene plants and other industries. So let me know if you'd like more information about these. Now we're going to discuss briefly a little bit more in depth the setup of cloud-based training. If you're not familiar with cloud storage, this setup allows for the standard model to be stored and run completely in the cloud and not on a local machine. Both the trainer and the trainee's machines communicate with the model, which runs in the cloud over the internet. This means you don't have to have a large amount of processing power on your local machine or any specialized local hardware. This also means the trainer and trainee do not have to be located at the same site or even in the same state. Both of them can access the model from anywhere that they have an internet connection. So now David with Axens is going to discuss troubleshooting.
So your digital architecture, your digital ecosystem in your plant has a number of different components, and we don't seek to displace those. These would be your historian system or your predictive maintenance system, your OTS if you have one, and your optimization software. We're looking to add to that a piece which effectively brings the licensor, the catalyst vendor, inside your architecture so that you can interact with us. And for that, we have ConnectIn. ConnectIn is a web-based solution that allows for data to be transferred from the plant to our calculation models in the cloud with data validation and reconciliation, and then including our results from our models. But it additionally allows the Axens technical service engineers to look at the data in real time and give advice on how the operation can be tuned and help with troubleshooting any issues occurring. And this has been deployed at this point to over 130 units out in the world, and there are more every day. So this is just ongoing number, keeps going up.
All right, so now we're going to move into our demos. So we're going to be doing a demo of both Indiss Plus as well as ConnectIn for you guys.
Hi everyone, my name is Nandita Akunuri. I'm a Senior Advanced Applications Engineer at Axens North America, and I'm here to introduce you to the Reforming OTS from Axens Advanced Training Service. The goal of this guided tour through the simulator is to present the visual and interactive experience as a trainee and the vast capabilities that the OTS can provide as an instructor. By the end of this video, we hope to show you that the Reforming OTS is a highly detailed and adaptive tool to create the perfect training course for your employees for your process unit. While we take reforming as a technology to demonstrate here, we have training solutions available for other process technologies that Axens offers technical support for. Let's get started. As you can see from the home screen of our simulator, the reforming OTS was designed by Accents and created by CORYS with their powerful simulation software, Indiss Plus. The combination of CORYS' years of simulation knowledge and experience, combined with Accents' reactor models and knowledge, helps make this tool one of a kind. Using the bottom bar as our navigation, we begin at the overview page. There are a total of 6 screens, 2 for the reaction section, 1 for the absorption section, and 3 for the stabilization section. For this OTS, the unit includes the reactor section with the feed and separation on one screen, where you have the heavy naphtha coming from the NHD going through the feed filters and into the feed effluent exchanger before getting combined with the recycled gas coming from the recycled gas compressor and going through the feed effluent exchanger into the reactor train. Here we have three reactors in. This is the first heater or the preheater, the first interheater, and the second interstage heater with 3 reactors. The reactor effluent from the third reactor goes back into the effluent feed effluent exchangers and into the separation section. So this is the reaction section with the feed and separation as well as the reactor screen. The absorption section has hydrogen compressors as well as the recontactor, where the gas and the liquid streams are recontacted for better separation. And in the stabilization section, we have 3 screens. The first screen has the stabilizer feed prep and the bottoms chloride adsorber section. The stabilizer column with the reboiler and the pumps. And we have the third screen with the stabilizer reflux drum and the LPG absorber drum sections. It is important to note that the OTS can be adapted for different process schemes for the different technologies, meaning that if your unit does not have a splitter tower, the process in the OTS will not have one either. We believe it is crucial that the process in the OTS is adapted and customized to be as similar as possible to your unit configuration, so that the benefits of the training simulation are maximized and the trainee gets the best out of the whole OTS training. So let's pick up one of the page as an example and go over some of the features of the simulator. Looking at the reforming reactor section as an example, the graphic interface gives the trainee several options to modify the unit operation. All of the control valves can be clicked in order to open the controller faceplates. And from here, the trainee can choose the controller mode, if it should be in manual or auto, place the controller in cascade if applicable, remote or local, and choose if the controller value should be tracked or not. When in manual, the output can be changed and the output value. And when you're in automatic mode, the set point can be changed. And when you click on this button, it expands the faceplate on the right, and it will give the trainee a trend view of the controller values, as well as the option to edit the controller tuning if necessary. Similar to the controllers, the indicators can also be clicked for more accurate readings. And if you click on this button, it expands the faceplate, and this also has a trend window, and you can see the high and the low points for this particular indicator. All of the controllers and indicators can be identified when clicking on the show button. So by default, there's a show hide button right here. So if you click on that, you can see the identifications for all the controllers and the indicators. Currently, there are 2 preset initial conditions, steady state operation and cold state. So when we have the whole simulation set up in steady state, the unit is online and running at the desired operating conditions, the design operating conditions rather. As you can see, the drums are at their appropriate levels. The reactors are all hot, and all the necessary equipment is all turned on. Whereas when we have it in cold state for the simulator, the unit is empty and it is not operating as if prepared to begin the unit startup procedures. The drums are empty, the reactors are cold, and no equipment is running. For the startup procedure part of the training, we start off typically the simulator in the cold state, and we work on the startup procedures and we run through it along with the trainees to ensure that there's in-depth learning and we don't miss out on any of the commonly occurred operational issues during startup, and we walk through the whole process using the training simulator as a practice. For the purposes of this demo, we will be using the steady state initial conditions. So let's take a few examples to understand how the training simulator can be used to help with the overall training. To best show the capabilities of the OTS, I'm going to run the simulation and make certain changes to the operation in order for you to see how the unit responds. By looking at operational changes and understanding the response of the overall unit, it gives a very in-depth understanding for the operators on what changes kind of lead to what kind of responses from the overall unit. So in the first example, we'll take at an operational change, which is to change the reactor inlet temperature for the 3 reactors. Right now, the reactor inlet temperature is set at 894 F for the 3 reactors, and we're going to reduce it by a little bit to see how the overall process responds to the change. Normally, big changes to the dynamic simulator will obviously emulate how the overall unit will behave to sudden drastic changes. Rather, in a training that includes a custom dynamic simulator, you will learn how to slowly walk down a unit from one change to one place to the other, and how to bring changes into the unit. So for now, for demo purposes, we're going to change the reactor inlet temperature from 894 F to 885 say, for the 3 reactors. So you'll see that the fuel gas to the 3 heaters will be cut down to be able to meet the set point of 885 F to the 3 reactors. Overall, all the reforming reactions, if you look at the overall net heat, they're endothermic in nature, which means the inlet temperature is actually higher than the outlet temperature in a typical reformer. So now when you reduce the inlet temperature going into the reactors, you're essentially reducing the driving force for the reactions to happen, which means the extent of reaction will be lower. So what you'll find is that the delta T should reduce when you reduce the inlet temperature, and therefore let's look at the delta T indicators. And if you click on the expander and if you look at the last 4 hours of data, so remember that we're running this on a fast mode. So what happened was that the delta T came down, reduced, and then stabilized at a particular point. And we see a similar trend for all the delta T's. The other thing that we will expect to see is that the recycled gas purity should increase because of the overall lower cracking taking place in the reactors. So if you go to the feed and separation page, and if you look at the recycled gas hydrogen purity, we see that it has increased over time. And we also expect that the net gas flow rate should decrease because there is, again, lesser cracking. So let's go to the hydrogen compressor page and look at the overall net gas flow rates. and we see that there's been a gradual decrease of the net gas flow rate. Another change that we expect to see is the reformate flow rate increasing overall. So let's go back to the separator section and look at the liquid. This is the reactor effluent, and that's going into the separator. And let's look at the separator liquid flow rate. And we see that it's gradually increasing. It's definitely going up. And what that would mean is overall the separator liquid eventually goes into the stabilizer, and the stabilizer level will gradually start rising, and the level indicator on the stabilizer is in cascade control with the flow rate of the reformate. So the reformate flow rate will be adjusted so that the level in the column will be maintained at the set point. So if we look at the reformate flow rate, we should see that it's increasing, but eventually it will start being controlled by the LIC, the level control, on the stabilizer column. And that will keep it constant, which is why it is important to make changes in steps rather than in big chunks. And that is one of the lessons that trainees would learn as a part of the dynamic operator training simulator. All of these changes can be seen on the trend pages. So there are trend pages set up for each of these sections, and if we go to the reaction section, there've been like 3 trend pages set up for all the indicators and the controllers, and you see all of them here. And if you want to customize them, you can open up the legend and you can give them alternate names so that it's easy to track across different process values for the different indicators and controllers. So as you've seen, this particular example was to show how the unit responds to operational changes, and in-depth understanding of how the process responds is very essential to anyone making changes to the unit operation. If you make a big change, I could have clearly shown you that the whole system fails, which we are going to demonstrate in the next example. But it's important to understand that one change in the unit at one place may cascade down to other parts of the process, and understanding the cause and the effect relationship between the overall unit is key. And that is one of the key lessons that we look at imparting to the trainees that take part in the operator training simulation. And because all of the safety interlocks and all of the safety stuff is customized to your unit, the operator gets a real world view of what would happen if they would change something. And that is important because when they work on the unit, it will help them decide if they should interact with the unit to avoid a possible unsafe operation. So in the second example, we will look at how the unit responds to an unsafe operation and how the trainee would interact with the unit to bring it to a safe operating place if possible. One of the most common fail situations in reforming units are recycled gas compressor trips. In this example, we will use a special feature that instructors have on the simulator called fail to be able to emulate a recycled gas compressor trip. I'll show you exactly how that works in a little bit. But for now, let's assume that the instructor has already set up a fail situation where the compressor is supposed to be tripping at some point. The whole exercise is to show how the trainees would understand how to look at different things and see what's happening in here. When the recycled gas compressor trips, the system sends out an alarm and several of the ESD valves close. Especially, you'll see that the feed to the unit is cut off. When hearing the alarm, right now I muted the alarm for the sake of the demo. When hearing the alarm, the trainee would go to the alarm summary page. So there you have a summary page to show which alarms are sounding, whether they were tripped low or high, and what the current value of that alarm is and the threshold it crossed. The trainee can acknowledge each alarm individually or all together. Since the emergency shutdown valves have been tripped, the trainee would also visit the shutdown logic page, where the shutdown logic has already been implemented into the overall simulator. Here they can see which shutdown logic was tripped, and clearly we see this one, which alarm caused the trip, and the actions that it has performed. From here, the trainee can also reset the shutdown logic in order to reset the emergency shutdown valves to try and begin restarting the unit. This is made easier by allowing the trainee to click on each specific action in red on the shutdown logic page and arrive on its appropriate screen. There can be some stations set up with an instructor mode of the training simulator, which gives the trainee access to the field operated devices. And once in the FOD mode, the trainee would reset valves and equipment that would require a restart. So this example shows that the OTS tool has a fully integrated alarm system and shutdown logic to help give the trainee valuable experience in reacting to emergency shutdown scenarios. However, to fully understand the vast number of emergency situations a trainee may face, we must visit the OTS from an instructor's point of view. So there are two versions of the operator training simulator. So far, we've seen the trainee version of the OTS. This is the instructor view that enables us to edit a lot of things and preset a lot of scenarios that would help train the operators to respond to abnormal operation of the unit. So the instructor view is similar to the trainee's view, except for some major differences. The most obvious one is the simulator toolbar that you see at the top. From here, the instructor can start, pause, or stop the simulation from running. They may also choose the speed at which the simulation is run. And we can also preset some, so I can stop, and I can also preset some initial conditions. For example, the recycled gas compressor trip that we looked at earlier has been preset here, and we can load it up for the trainees, and we can train them up on what they are supposed to look at and how they would come to the conclusion that the recycled gas compressor has tripped. If the instructor decides to create a new set of initial conditions, for example, a scenario where the unit is running at turndown rates, they could run the simulation to their desired operating conditions and then save it as a new initial condition using the snapshot function. Next is the FOD mode. So on the bottom right, you see a few additional modes that are not available in the trainee version of the software. Under the FOD mode, the trainee can see all the additional field operated devices that exist in the unit. For example, if you go here, in the trainee mode, you would not be able to stop or start the compressor, but in the instructor mode, you can have access to all the field operated devices. The FOD mode also allows the trainee to click on equipment such as pumps to start or stop and valves to control the surrounding block valves or manipulate globe valves that may be out in the field. This is especially useful in the startup and shutdown procedure training. And finally, the FOD mode gives the trainee the option to edit the pressure of the boundary limits on the training system. Next is the hand holding a pencil in the bottom right corner. Clicking on the hand allows the instructor to edit the conditions and the content of the feeds or utilities at the boundary limits. You see the little pencil that comes in here. So clicking on that would help you edit it. This is both helpful in providing different training scenarios and customizing feeds to best replicate your unit. Finally, there's the small lightning bolt. Clicking on this button reveals several other lightning bolts. I don't know if that's clear enough, but there are these small lightning bolts across the simulation screen. These bolts represent an equipment or system malfunction that can be introduced into the simulation. So earlier we did the recycle gas compressor trip, and the way we set it up is we set up a motor failure and we gave it a delay of 30 seconds and we saved that scenario. And when we run that scenario, after 30 seconds of run time, the compressor trips and then all the alarms are activated, the emergency shutdown valves are activated, and the system responds the way it is supposed to respond to a particular fail. For pumps, a motor or coupling failure can be simulated. For a valve, a fail, open or close or stuck position can be enforced. For a controller or instrument, the value could drift or fail, high or low. Even heat exchangers can be simulated to show fouling in the shell or tubes. These malfunctions allow Accents to create a large portfolio of exercises to ensure that trainees are best prepared for actual unit operation. This concludes our tour of the OTS tool. We hope this video has proven that our advanced training simulator is the perfect tool to help educate your employees on the safe and optimal operation of your process unit. Thank you for watching the demo.
All right, thank you, Nandita, for that. And now we are going to move into our demo of Accents Connect In.
As we discussed previously, we have a tool called Connect In, which allows us to monitor the performance of units out in the field. And this also helps with troubleshooting those units. In this case, we have a demonstration unit, so it's not using actual data from any particular plant. It's a CCR unit, and that is a reformer. What we see on the screen right here is a dashboard which shows the current operation, or the last operating data that came in for general performance data, shown here, and for the catalyst data, shown below. In this case, these would be customized to the unit in particular. As we can see, we can easily tell the difference between good data and questionable data, or rather good data and things we need to look into. In this case, we have green, showing that the operation is within the expected parameters, orange, which is questionable, and red, which is outside of the normal parameters, or in this case, above. If we looked at this particular data point, that was the operating temperature of the reactors, the weight. We saw that it was relatively high. But if we look back, we see that it's operating relatively high for the entire time that we're showing. We can change the data period, the time period, for as flexible as we have data. And that brings up some other things. We can also see where there are some points that are noted. In this case, the catalyst was, the chloride injection was stopped. We can see that the operation for various things is operating relatively normal in this case. Additional to the last operating data page, we see that the catalyst sample data is also on here, but also the catalyst velocity inside the inside the unit. On top of that, we also have alerts, and alerts are for tracking the unit in case the operation of the unit goes outside expected parameters. An alert will be issued to the technical service engineer and the unit engineer from the client, so that we know what's going on and we know something's happening. And it really is just information that's used to go and look and make sure that everything is operating as expected. It could be as simple as changing the specifications on the unit operation. We calculate a variety of things, and we collect those in different dashboard groupings, folders. We have, for example, reconciled yields, which shows the yields out of the reactor, both normalized and raw data. So the normalized data is normalized for feed flow rate and things of that nature, and the operating octane target, I believe. The catalyst, we can look at the catalyst regeneration, for example, if we have that data. And in some cases, we don't have that data because we are not the licensor for the unit. But in this case, we would have the data. And we can also track just general operating performance. So if I look at the reactors page, for example, we can see that the delta P in the reactors and the temperature in the reactors is fairly consistent, particularly because this is a continuous reformer. The delta T is not moving from one reactor into the next reactor. It's basically constant through the entire life. If I look at the last 2 years, we'll see that it's basically constant over those 2 years. Similarly, we can look at, obviously, analysis data for ref-made feed and gas and catalyst. But this isn't just a tracking program. This isn't just taking the data from the client system and plotting it for ourselves. While that will be useful, we're also doing calculations. And those calculations are important for things like normalization, but also for predictive modeling. And if we look at the predictive models portion, in this case, they're called what-if tools. The what-if tools show, in this case, the performance. They predict the performance. So if I take the current operation and load it up, and then I change, for example, the weight from 543 to 540 and run the model. The model runs actually very quickly and comes back and tells us that the operation will have, again, -3 degrees C weight, temperature, spread across the various reactors. The delta T across the various reactors will decrease, but the rod will also go down, and the outlet octane number will go down by 0.4 number. And obviously the distribution of components will also change. We can change the feed composition and the other operating parameters as well to show different operations for the same operating point with the same catalyst load from the current operation. And that's a useful tool for doing projections of the refinery in real time. This sort of information can be connected directly to a simulator, for example, to preload a dynamic simulator with the current operating conditions, or a steady state simulator for that matter. But we are talking about dynamic simulators today. In any case, I'm going to move on from this demonstration and we can talk about the questions and answers that might come up.
All right, so that concludes our demo portion of the presentation. So now we're going to move into question and answer. We've had quite a few questions come in over the course of the presentation. If we don't have time to get to your question, we will be emailing you individually with an answer, because we want to make sure everyone gets an answer. But we do have a limited amount of time here. So the first question that we had come in, or one of the first questions we had come in, was about keeping the OTS up to date. Someone asked a question about, do we provide OTS maintenance? And the answer is yes, we do. We believe it's extremely important for operators, trainers to maintain that faith and trust in the model. So it's very important for us to make sure that anytime you have a change in the plant, we represent that in the simulator as well. So we provide, we offer maintenance contracts where our engineers can do maintenance on your model to keep it up to date. Every time you have an MOC, we can make that change. And we also offer training for your trainers, your process engineers, your controls engineers, whoever you want to have maintaining your model. We can train them to do that, or we can do it ourselves, depending on what your resources look like in the plant. So the next question that we had, I think Dave had a question about connect-in. Let me see if I can find that one in our Q&A.
Is it the one where can we feed the data to connect in?
Yes.
Okay, so effectively the answer is yes. We can attach data from the plant. We can bring in correction factors or fouling factors or reactivity numbers for the reactors into Indiss Plus to change the way that it behaves, and we can basically seed the simulator with that data.
So we also had a couple questions come in about our standard models. So we had a couple people ask about what different HMI can we provide, what different DCS and SIS we can provide. So we work with all major DCS, SIS vendors. What you saw today was our standard base plates, but we offer a variety of different HMI based on whatever DCS you have. We also had someone ask about the number of trainers and trainees that can access the cloud-based model at the same time. And the answer to that is it's almost unlimited. You can, based on your subscription, you can have any number of trainers or trainees accessing the model at the same time. We also had a question come in about third-party kinetics and thermodynamics, and asking if we can incorporate those. The answer is yes, we can. We can incorporate those third-party components via the CAPE Open Interface standard. If you have proprietary kinetics or something that you're concerned about, we can black box those so that they're sealed off and separate, so we can maintain, any kind of security concerns that that you might have. Additionally, something that some of you asked about that we didn't have time to get to today was there is a scoring and assessment feature within Indiss Plus. So you can create automatic training exercises in order to test your trainees on different training scenarios, different malfunctions. And there is a feature in Indiss Plus which will automatically monitor your trainees' performance based on different parameters that you set, such as a temperature or a pressure that you want to keep within a certain range. And then it will automatically generate a report for you, and it will score your trainee if you want, but it doesn't have to score your trainee if that's not something that you want. We just didn't have time to include that in our demo today, but I know several of you are interested in it based on your comments in the Q&A. So please send me an email and we can set up a demo for you about our training performance monitoring. Let's see what other questions we had. Someone asked if we will receive a link of the webinar. The answer is Yes, you will. So we are recording this, and I will send out a link to all the participants afterwards. Dave, do you see any other questions that you want to speak to?
So for everyone who's asking about different types of plants, polymer plants, petrochemicals, etc., the answer is yes. This can be used to demonstrate those or create a simulator for those, and has been for a lot of different ones. I assume the answer is true for power plants. I don't deal with power plants, so I don't know the answer for that.
Someone asked about, oh, I'm sorry, Dave, keep going.
Oh, go ahead.
Someone just asked about APC implementation. Can you include an APC implementation into the models? And the answer to that is yes. There's a lot of questions about, can you include, do we supply a certain DCS faceplate and things like that? And the answer is generally yes to all those things. We're pretty flexible on what we can incorporate into these models.
So this is Greg. There have been a lot of questions about what kind of processes that we can model. There was one on a particular process. So you have our email. If there are any particular units that you're interested in, just let us know and we'll give you our experience list or talk to you about it. But it's certainly a lot more than what you're seeing here today. There was also a question on which reformer this is. And this is based on AXENS design, but we cover all types of unit configurations and all the process licensors.
Yeah, thank you, Greg. So we had a question about link versus emulation. So emulation is where the controls are incorporated into the model itself, as opposed to a link system where our model communicates with a set of soft controllers. It's a replica, an exact replica of your DCS. And the short answer to that is yes, we do emulations as well as linked systems. So we can work with both there. We had a question about can we cover simulations where plant equipment performance decreases, for example, heat exchanger fouling. So yeah, we can simulate heat exchanger fouling. We can simulate leaking valves. I think you saw Nandita go over some of that in the demo. If there's
Catalyst
any
deactivation.
I'm sorry?
Catalyst deactivation, for example.
Yes, and if you have custom malfunctions that are specific to your facility or your plant, we can also model those. So if you have any specific questions about, can you model this for specific problem, just feel free to send me or David an email and we can answer that.
So there was one question about computational fluid dynamics and how that differs from operator training simulators, and they're just basically different things. This is process level. It does deal with flow through the pipe network, and it deals with valve sizing and valve opening sizes and the size of the actual equipment, but it doesn't deal with the flow inside the equipment for the most part. There are some pieces of equipment which it does, but for the most part it does not. And so the computational fluid dynamics would tell you how the flow inside of a piece of equipment would behave, rather than how the OTS would show how the actual reactions are happening and overall.
Yeah, thanks for that, Dave. I saw that question, and so I just wanted to say one thing about the standard models, and we've had a number of questions on how long does it take to build a model and what is the cost and those kind of things. Well, we have a number of on-the-shelf models that are standard models. So all the refinery models are available immediately under a sort of a term lease type contract at a low cost. They're high fidelity, they don't match your unit, but they're pretty close to, say, the configuration of a typical crude unit or a cat cracker. But the custom models that are bespoke and plant specific, those are kind of full-blown engineering projects. They typically take 12 months to implement, and they're usually associated with DCS migrations or greenfields projects. and it's a different thing. So we kind of have two different approaches to this. So Sarah Grace, do you want to just mention anything about training as a service?
Yeah, so we offer training as a service, like Greg mentioned as well. We offer training for all of your trainers, and we offer subscription, like we spoke about in the case study. We offer a subscription to our standard models. The standard models are hosted in the cloud, so there's no license fees, there's no hardware cost. It's just a monthly lease on those. And those come with a companion training manual, which describes different scenarios and how to use those for training. So those are really great if you have an organization that's less experienced with simulation-based training. They're a great way to kind of get your feet wet with simulation-based training for a very low startup cost as opposed to custom models. And we've found that, once our customers start using the standard models, they get acquainted with them, they become more interested in custom models long term. So you can kind of trial a standard model, and then if it works really well for your organization, we can always develop a custom model for you later.
And they're fully functional, self-serve, so you can change your own scenarios. You can use our companion training manual as a starting point or as a template. But there were a number of questions: can you do different initial conditions? Can you reset the conditions to the startup or the normal operating? And the answer to that is all yes, through just saved initial conditions or snapshots that were made during model runs. So it's really easy to use. Even I can use it.
Thanks, Greg. Well, I want to be very respectful of everyone's time, and I really appreciate all of your participation. If you haven't had a chance to answer our poll questions, please go ahead and do so now before we end. And one last thing before we go, since we're running out of time, I wanted to mention CORYS's simulation conference that is taking place in October of this year. We'll have clients talking about simulator best practices and train the trainer sessions. So all the questions that you have today will be answered at this conference, but of course we'll also be emailing you individually to answer your questions. But if you want to learn more about dynamic simulation and see some of our customers speak about it themselves, this is a great place to do that. It's going to be a great time. It's in Orlando, and we'd love to see you there. So let me know if you're interested. So we had some questions we weren't able to get to, but we will be emailing you with individual responses, and you will also receive a copy of a recording of this webinar if you'd like to forward it to your colleagues or watch it again later. My contact info, as well as David's contact info, is on the screen. So please email us and reach out if you have any questions. Thank you so much for your time, everyone, and have a great week.